So the next is propanoic acid. Propanoic. Now, having seen propanoic acid, what would be the molecular formula for propanoic acid? If you recall, dear students, that we have said the addition of CH2 to this will give us the next compound, because each member in a given family differs from the next by a CH2. So that implies that if I'm to get my molecular formula for propanoic acid, having known that for ethanoic acid, this is going to be C2H5 COOH. COOH is like a constant for all of them. So adding CH2 to CH3, that will give me C2H5. And then I pen down my COOH. So in a nutshell, we have 3 carbons and 6 hydrogen and 2 oxygens. Now, I would like to also let us know that the compound C2H5OH can also be written as CH3 CH2 COOH. So take it at the back of your mind that you can also write it this way. It is still acceptable. There is no problem about that. So talking about the structural formula now, we have 3 carbon atoms there. So this is going to be 1 carbon, 2 carbons, 3 carbons. And this is double bond. This is double bond. For the last carbon, this is O and this is OH. So we have 5 hydrogens to be distributed between these 2 carbon atoms. The middle carbon atom is already having 2 bonds, so it's going to need just 2 hydrogens to make it up to 4. And then we have the balance of 3 hydrogens going for this other carbon atom. And this is the structural formula for propanoic acid. It goes on and on and on. The condensed formula for propanoic acid therefore will be CH3 CH2 COOH, just like we have written before. This is the condensed formula for that compound. Okay, now I'm going to give us one more, which is butanoic acid. Butanoic acid for proper clarification and understanding. So let's look at butanoic. Butanoic is number 4. Butanoic acid. So that's butanoic acid. Butanoic acid will be, if I am to add CH2 to C2H5COOH, that will give me C3H7COOH. COOH is a constant parameter for all of them. So that is my butanoic acid, and that means I have 4 carbon atoms, 1, 2, 3, 4. Since they all have single bonds between them, that's going to be that. This oxygen, this OH. So, if I am to label the carbon atoms, let's say this is, now, I'm going to tell you why it's going to be that way. Let's begin our labeling from here, because this is the functional group and preference must be given to the functional group. You will get to understand that later. So we have the first carbon atom from the right hand side, the second, the third, and the fourth. So it means that the first carbon atom is complete with 4 bonds. 2 from oxygen, 1 from OH, 1 bond from carbon 2. The carbon 2, the second carbon atom, is having 2 bonds. 1 from carbon 1 and 1 from carbon 3. Carbon 3 itself is having 2 bonds. 1 from carbon 2, 1 from carbon 4. And carbon 4 is having just 1 bond, which it's sharing with carbon 3. So it implies that carbon 2 needs 2 more hydrogens. And there it goes. Carbon 3 needs 2 more hydrogens. And there it goes. While carbon 4 will take the remainder 3 hydrogens. And there it goes. So this is the structural formula for butanoic acid. What will be the condensed formula? The condensed will be CH3, CH2, CH2, COOH. That is it. So this is how to write the structural and the condensed formula for any given hydrocarbon. Having seen that, I would like you students to go ahead and put yourself to the test by writing down the structural and condensed formula for pentanoic acid, hexanoic acid, and heptanoic acid. And I believe you will be able to do justice to that. So let us proceed to the next homologous series.